2, 1, 2, 3.
This is Alan, and this is Ron. And we're a group of electronics engineering students currently taking up the course Strengths of Materials or MEC32 under Engineer Melchor F. Pilones of the Department of Civil, Environmental and Geological Engineering. Now, recently, he had us think of a project that would relate whatever lessons we learned under the subject to what we usually deal with in our course. What we came up with was this, a Bluetooth-controlled double-leaf Bascule bridge. For a demonstration,
so we will use an Android phone to control the bridge. So this is the full-time application. And then I will press the letter U to move the bridge upwards. So as you heard, we use a buzzer to signal that the bridge is going upwards or if it's moving downwards. So I will now demonstrate the downward movement of the bridge.
our project is a model of a common type of movable bridge that's been in use since the ancient times. This is none other than the Bascule bridge. A Bascule bridge, commonly referred to as a drawbridge, is a movable bridge that swings up to provide clearance for boat traffic or down to allow vehicles to pass through. It may be single leaf with a single moving span as shown, or double leaf as seen in this picture. The two bridge spans in our project are wirelessly controlled by an Android device via Bluetooth through an application called BlueTerm available on Google's Play Store. In addition, we used an Arduino microcontroller along with a Bluetooth module and some other motors to control the bridge, but we'll discuss that further a little bit later. The project's double-leaf bridges are basically just painted popsicle sticks that are connected together in a Warren truss formation. The Warren truss is a simple type of truss bridge designed in 1848 by James Warren. It consists of longitudinal members joined only by angled cross members forming alternately inverted equilateral triangles.
List of materials: popsicle sticks, glue or wood glue, acrylic, newspaper, tissue paper, paint, miniature trees, powdered grass, chloroform, Arduino microcontroller, Bluetooth module, connecting wires, 2 servo motors, Android phone, and BlueTerm application.
I don't care, baby, by the way. Because I'm happy. Clap along.
Procedures. First, build the Bascule bridge model using popsicle sticks and wood glue. We combine the 3 popsicle sticks to make it more substantial. To create a truss in both sides, we arrange the popsicle sticks like an equilateral triangle, then continuously glue it. To create the base of the bridge. We also put a support at the bottom of its base. The output of Bascule bridge model using popsicle sticks. To create the base, we arrange the acrylic in their certain designation and glue it by chloroform. We also cut some acrylic to support the weight of the water. Then, for the hinge, we glue the specific position of the acrylic and drill it. We also test if there is a leak. Output of the base of our project. Screwing the servo motor. We use paper mache to simulate the texture of the lamp. We put a miniature case and sprinkle the powder grass.
You bring me to my knees, you make me testify. You can make a sinner change his ways.
For our sample combinations, we will show you how to solve for the reactions and draw shear and moment diagrams for our bridge. Our bridge have a uniform load of 9.07 Newton per meter and a total length of 0.54 meters. So in order to solve for reaction B, we take a summation of moments along point A. Then we have reaction B times 0.54 meters minus equivalent force times 0.27 meters equal to 0. Then we have reaction B is equal to 1/2 equivalent force. And our equivalent force equals to 9.07 Newton per meter times 0.54 meters. Then we get a value of 2.4489 newtons. In order to solve for reaction A, we take a summation of forces along Y. Then we have reaction B plus reaction A minus equivalent force equal to 0. Then reaction A is equal to equivalent force over 2. And we have 2.4489 newtons also. Now guys, we'll show you how to make our shear diagram. So starting at point 0, we have an upward force of 2.4489 newtons. And in order to get the force at the end of the bridge, we multiply our uniform load, which is equal to 9.07 Newton per meter, to 0.54 meters, and we get 4.8978 newtons. And we subtract it from 2.4489 newtons. Therefore, we have our value of negative 2.4489 newtons. And since we have a uniform load distribution, this is equivalent to a line having a downward slope. So we draw it from 2.4489 newtons, then crossing at the x-axis and to negative 2.4489 newtons. In order to get the distance at the x-axis, we divide 2.4489 newtons with 9.07 Newton meter, and we get 0.27 meters. Now guys, we'll show you how to make our moment diagram. So based from our shear diagram, from point 0 to 0.27 meters, we have a line with a downward slope above x-axis, and it is equivalent to a upward second degree curve in our moment diagram. So in order to get the moment value at 0.27 meters, we use the formula of the area of a triangle. So for our base is 0.27 meters, and for our height is 2.4489 newtons, and we get the value of 0.3306 Newton meters. And for the end of the bridge, we have a line with a downward slope but below x-axis, and this is equivalent to a downward second degree curve. And since it is downward, we just subtract 0.3306 Newton meters from our previous value and give a zero moment.
Go!
So how exactly is this project related to electronics engineering? Well, mostly has to do with the circuit involved. Our circuit is composed of an Arduino microcontroller, a Bluetooth module, two servo motors, a buzzer, and a battery for power supply. An Android phone will be used to control the bridge, but actually, any device with the application called Bluetooth downloaded from Google's Play Store can be used. This application will be used to transmit data to the receiver, which is the Bluetooth module. To control the motion of the bridge, commands will be input from the device. Pressing the letter U causes the bridge to move down upwards, and the letter D should be pressed to move the bridge downwards. The Arduino will process the signal received by the Bluetooth module and uses it to control the movement of the bridge wirelessly.
Open up your gates, 'cause